let's take a look at an example. This example is going to deal with motion involving gravity. So suppose a ball is thrown in the air from a height h0, which will be the initial height, at a velocity of v0, the initial velocity. The height of a ball above the ground is given by y equals h of t equals negative 16t squared plus v0t plus h0, where t is in seconds and height will be in feet. So you'll notice this is the general form. So typically we are given v0 and we're given h0. But this would be the general form. We'd have negative 16t squared plus, we would substitute in the initial velocity times t plus the initial height. So here's our example. Suppose a ball is thrown from ground level at a velocity of 96 feet per second. Give the equation for the height of the object after t seconds. Well, as we recall, the formula is h of t is negative 16t squared plus v0t plus h0. So if I substitute in what I know, I need the initial velocity, and they're told me from a velocity of 96 feet per second, so that would be 96, and we'll put the t in, plus, and we're throwing it from ground level, so the initial height is 0. So that would be our part A, and again, we could leave the 0 off. What is the height of the ball at 2 seconds? Well, 2 seconds is a time, so what I need is h at 2, and h at 2 would be negative 16 multiplied by 2 squared plus 96 times 2, so that's negative 64 plus 192, which appears to be 128, so 128 feet. So the particular ball would be 128 feet above ground level. Part C, when does the ball hit the ground? Well, the ball will hit the ground when the height equals 0. In other words, from our previous definition, we're actually looking for one of the zeros of the quadratic function. And so what we do is we take our formula that we had, negative 16t squared plus 96t, and we set that equal to 0, and we solve. Now notice both of these have a t that's common, and in fact they both have a 16 that's common. So I could actually take out 16t, which would leave me with negative t plus 6 would equal 0. And if I do this, I end up getting t equals 0 when I set the first piece to 0, and t equals 6 when I set the second piece to 0. Now the t equals 0 makes no sense, because that's not when it hits the ground. That's when it's actually leave the ground. Right? That's the time when it leaves the ground. And so the t equals 6 is when it hits the ground. And so that would be the answer to part C. Now, the part D asks us, when does the ball reach its maximum height? Hopefully you've done some work before with quadratic functions, and what you would realize if we graphed this one, and if not, graph it on your calculator to convince yourself, that here we are leaving the ground at 0 seconds, returning to the ground at 6 seconds, and so therefore, because parabolas and quadratics are symmetric, as we saw with the axis of symmetry, it must reach its maximum height halfway between 0 and 6. And so it's going to reach its maximum height in 3 seconds. Now, the last thing we want to do here is find the maximum height of the ball. And so now I know that it reaches its maximum height in 3 seconds. So what I do is I compute h at 3. So I'd have negative 16 multiplied by 3 squared plus 96 times 3. And if I do that, pull out my calculator, negative 16 times 9 plus 96 times 3 gives me 144 feet. So this point is actually at 144 feet. So the point itself is actually at 3, comma 144. If we wanted to, we could actually talk about the axis of symmetry. The axis of symmetry here would be x equals 3, or since I used the variable t, I might want to call it t equals 3. Now you'll notice at the bottom of your notes I gave you a better looking graph than the one that I actually drew for this particular example.